Good morning to all of you. I am Swati from BSc Chemistry Honors second year, fourth semester. Acid and base. Arrhenius concept of acid and bases. Arrhenius, a Swedish chemist, was first to define acid and base in aqueous solutions. According to Arrhenius, he defined acid as a substance which contains hydrogen and which when dissolved in water gives hydrogen ions. According all mineral acid like HCl, HNO3 and H2SO4 containing hydrogen when dissolved in water completely into hydrogen ion as HCl dissolved in water give H plus ion and Cl negative ions. HNO3 react when dissolved with water gives H plus ion plus NO3 negative ion. H2SO4 gives 2 H positive ions plus SO4 2 negative ions. Arrhenius named these acids which dissociate completely in water as strong acids. There are some other acids like acetic acid, carbonic acid, phosphoric acid, which when dissolved in water do not dissociate completely into ion. As a result, an equilibrium is set up between the ions and the undissociated acid molecule as shown below. CH3COH dissolved with water gives H plus CH3CO negative ions. Arrhenius named these acids as weak acid. According to Arrhenius, a base is defined as a base is a substance which contains hydroxyl group and which when dissolved in water gives hydroxyl ion OH negative ions. Thus substances like NaOH and KOH which when dissolved in water dissociate completely to give hydroxyl ions as NaOH gives Na plus OH negative ions. KOH gives K plus OH negative ions. Arrhenius named these bases which dissociate completely in water as strong acid. There are substances which do not completely dissociate in hydroxide ion. Arrhenius named these substances as weak base. For example, substances like NH4OH, MgOH twice, AlOH thrice do not dissociate to give OH negative ions are named as weak base. NH4OH gives NH4 plus OH negative ions. MgOH twice gives Mg2 plus 2OH negative ions. Hydrogen ion obtained from acid and hydroxyl ions obtained from the bases combined together to form unionized water. Arrhenius described this combination of H plus and OH negative ion as neutralization reaction. NaOH gives Na plus OH negative ions. HCl gives H plus and Cl negative ions. Combining both we get Na plus OH negative plus H plus Cl negative. OH नेगेटिव प्लस H पॉजिटिव कंबाइंड करके H2 बना लेंगे और Na प्लस Cl उनके साथ ऐड हो जाएंगे. अगर उनको दोनों साइड से कॉमन जो साइड है उनको काट देंगे तो हमें मिल जाएगा H प्लस OH नेगेटिव यानी H2 उसका न्यूट्रलाइजेशन हो जाएगा. Arrhenius concept is very simple to apply and explain a number of phenomena like neutralization, hydrolysis of salt, strength of acid and bases. However, there are certain limitations which are described below. Arrhenius concept of acid and base is applicable only in aqueous solution. This concept fails to explain. Arrhenius explain concept fails to explain the acid and bases concept of acid and bases applicable only in aqueous solution. He explained this. This concept failed to explain acid or base behavior of substance in non-aqueous medium such as liquid ammonia, liquid sulfur dioxide, alcohol, etc. Arrhenius also fails to explain एसिडिक और बेसिक करेक्टर ऑफ सब्सटेंस जैसे CO2, SO2, SO3, NH3, Na2CO3, CO extra. He also fails to explain the reaction between an acid and a base in absence of water. Example: NH3 plus HCl gives NH4Cl. Arrhenius' concept of acid and base suffers from a number of limitations, yet the concept is very useful and informative for a elementary approach. Second scientist, Bronsted-Lowry concept. Arrhenius' concept of acid and base was further improved. एक साइंटिस्ट था जिसने इसको इम्प्रूव किया था, ब्रोंस्टेड लोवरी कॉन्सेप्ट. ब्रोंस्टेड एंड लोवरी, both Bronsted and Lowry in 1923 incidentally introduced the same definition of acid and base. According to Bronsted-Lowry concept, an acid is defined as: an acid is a substance which can donate a proton H positive, where a base is a substance which accept a proton H plus. यानी कि एसिड एक प्रोटॉन डोनर है और बेस एक प्रोटॉन एक्सेप्टर. According to Bronsted-Lowry, neutralization in reaction involves release of proton by an acid and acceptance of an proton by a base. For example, reaction between HCl and NH3 to form salt ammonia can be represented as NH3 plus HCl gives NH4 positive plus Cl negative ions. The curved arrow shows how electron must rearrange to result in transfer of hydrogen atom from the acid to a base. The unshared pair of electron on the nitrogen of ammonia, इस अमोनिया पर जो अनशेयर्ड पेयर ऑफ इलेक्ट्रॉन है अट्रैक्टेड बाय पार्शियल पॉजिटिव चार्ज अट्रैक्ट किया जाएगा, जो HCl पे H के ऊपर जो पार्शियल पॉजिटिव चार्ज है उसे अपनी तरफ अट्रैक्ट कर लेगा. इन पोलर हाइड्रोजन क्लोराइड मोलिक्यूल, a proton has been transferred from chlorine to nitrogen. To act as a Bronsted-Lowry base, a specific must have at least one unshared pair of valence electrons so that it can form a covalent bond to the proton. To act as a Bronsted-Lowry acid, a species must contain at least one hydrogen atom that is attracted to an atom that is more electronegative than hydrogen. HCl loses a proton and is an acid. Ammonia accepts a proton from HCl, so ammonia is a base. This concept is given by Bronsted-Lowry concept. Bronsted and Lowry after Arrhenius. Some example of acid-base reactions according to Lowry-Bronsted concept are HCl, which is acid, and H2O as base gives H3O positive plus Cl negative ions. H2O plus NH3 gives NH4 positive plus OH negative ions. It is very important to note the above examples. Water act as a base with respect to hydrochloric acid and sulfuric acid. Water बेस की तरह रिएक्ट करेगा सल्फ्यूरिक एसिड और HCl के साथ. वाटर एक्ट एज एन एसिड और अमोनिया के साथ वाटर एसिड के लिए यूज़ करेगा. सच ए सब्सटेंस विच एक्ट, जो बोथ एसिड और बेस दोनों हो, प्रोटॉन डोनर भी हो और एक्सेप्टर भी हो, दीज सब्सटेंस आर कॉल्ड एम्फोटेरिक सब्सटेंस. Bicarbonate ion behave as an acid or base, so it is example of amphoteric substances. Next topic is conjugate acid base pairs. HCl plus NH3 gives NH4 positive plus Cl negative in aqueous. HCl being an acid donates a proton and form Cl negative ion, whereas ammonia being a base accept a proton and form ions. Now the chloride ion has a tendency to accept the proton, whereas ammonia ion NH4 positive have a tendency to donate a proton. In other words, sorry. In other words, an acid donates becomes a base and an acid donates electron becomes a base and a base accept a proton becomes an acid. Thus, a base formed from an acid is regarded as the conjugate base of the acid. Similarly, the acid conjugate acid of base NH3. Acid and bases, they are related by loss or gain of H positive ion, are called conjugate acid pairs. Thus, Cl negative and HCl, NH4 positive and NH3 are conjugate acid base pairs. We can represent acid base pair as acid is conjugate base plus H positive ion, and base plus H positive ion is conjugate acid. It is clearly indicate that any acid base reaction would involve two acid and two bases. These acid bases are called conjugate pairs. For example, acid 1 plus base 2 gives acid 2 plus base 1. HCl plus HCl acid, H2O base, H3O positive conjugate acid, Cl negative conjugate base. In above example, HCl is an acid since it donates a proton, and Cl negative is its conjugate base. Water accepts the proton and hence is a base. Thus, S3O positive ion is conjugate acid. A strong acid has a weak conjugate base and vice versa. Some example of conjugate acid base are below. Acid 1 plus base 1 gives acid 2 plus base 2. HNO3 plus H2O, H3O positive plus NO3 negative. H2O plus H2O gives S3O positive ion plus OH negative ion. H2O plus CO2 negative ion gives S3 HCO3 negative OH negative. It is further important to note the Bronsted-Lowry concept is not restricted